Alright, Chapter 9, Test Review. So first thing we'll do is we'll go through just a basic stoichiometry problem, starting from grams of known, asking for an answer in grams of unknown. If you can do this, you can do any of them. Remember, if you don't need the full grams of known all the way through grams of unknown, you just get to stop in the middle. But remember, the general equation is if this is the side of my known, I have grams to get to moles, I have to divide by the formula mass. To go from moles of my known, moles of my unknown, this is multiplied by the ratio from the balanced equation, and then to further get it into grams of my originally my unknown, I have to then multiply by the formula mass. So, tin 2 fluoride, which is SnF2, tin 2 fluoride, is used in toothpaste. This is the sample problem E on page 310. Made by the reaction of tin with hydrogen fluoride according to the following equation. So we have Sn plus 2HF yields SnF2 and H2. Okay. So the question is how many grams of tin 2 fluoride are produced if I start with 30 grams of hydrogen fluoride and I react it with a tin. So my starting point is 30.00 grams of HF. Well, the first thing, so my known is in grams, so the first thing I have to do is then convert it to moles. Alright, so we have to figure out the formula mass of HF, which is 20.01, because I have H, that's 1.01, plus 1F, which is 19, 20.01 grams per mole. So I set it up. Remember, this is my starting point, so that's what goes first. Write down your units, grams of HF, all over 1. All right, my fraction, moles of HF. So then I'm going to divide by the formula mass. The grams would cancel. Then I use my ratio to get it to 1 mole SnF2. Ratio is 2 moles HF, and then I'm going to multiply that to get rid of moles of HF. Get rid of 1 mole SnF2 to grams of SnF2, and the formula mass for tin 2 is 156.71. So 156.71 grams. Then we go through and we check everything. I've got grams of HF here and a gram there, so that cancels. I've got moles of HF and moles of HF there. I've got moles of tin 2, moles of tin 2 left with grams, so that's good. Do all the math, and I get 117.5 grams SnF2 with 4 significant figures. Okay. So limiting reactant one. Be a little bit longer. The example on page 314 in your book. Black oxide of iron, Fe3O4, occurs in nature as a mineral magnetite. This substance can also be made in a laboratory by the reaction between red-hot iron and steam, according to the following equation. 3FeS plus 4. Actually, you know what? Granted, it's in your book, but let's just work on balancing just for fun. So FeS plus H2O, gas that is steam, yields Fe3O4. This is a solid and H2 gas. Alright, so let's try to balance it. Well, obviously, we've got a 3 here. I'm going to have a 3 here. Alright, so we're going to do oxygen last. With 3 Fe's, I've got some unknown amount here. Well, 4 oxygens means I'm going to have at least a 2 here, which will give me 4 H's, which means I would put a 2 here. Alright, we'll see if that in fact works. Nope. Why not? 4 H's, 4 H's. I got 8. Oh yeah, because this is a 4, not a 2. So I can't put a 2 there. Wow. Alright, so now we have it balanced. So now we can do the first question. When 36 grams of H2O is mixed with 67 grams of iron, which is the limiting reactant? Alright, so my starting point is 36.0 grams H2O. Remember, these are my reactants. Those are the only two I get. Those are my reactants. This is my products. All right. So I pick one product and I work from there. Okay. I don't get to start with hydrogen gas or anything like that. 67.0 grams of iron. Well, first step from up here. Have to convert everything to moles first, right? 36.0 grams H2O over 1. 1 mole of H2O, same thing as 18.02 grams H2O. So that's essentially 2, but we're not going to go that. Well, 36 divided by 18.02, 1.9978 moles H2O. And I do the same thing, 67.0 grams of iron. 1 mole of iron is 55 grams of iron. So 67 divided by 55.85, 1.1996 moles of iron. Alright, so now that I know how many moles I have, I need to ratio that to one of my products. I'm going to pick the... Let's go hydrogen gas. Alright, so first step we'll ratio this one. Next step we'll ratio the other one to the same product. Alright, so this is step 1, get everything in moles. Step 2, figure out which one makes the least product. So I have 1.99778 moles of H2O. That's my starting point. Ratio it. In this case it's a 4 to 4, so 4 moles of what I'm looking for. My product up here always goes here. So 4 moles H2, 4 moles H2O. That's pretty easy. That's 1.99778 moles of hydrogen. That's the first run through. All right. Now I do the same thing with my iron. 1.1996 moles of iron. I still have 4 moles of hydrogen, and I have ratio that to 3 moles of iron. So I take 1.1996 and multiply that by 4, divide the answer by 3, and I get 1.5995 moles of hydrogen produced using the amount of iron. So this is the smallest of these two numbers from here to here. So that is the most of hydrogen I can make, and because that was run using iron, iron is my limiting reactant. Okay? So then the next question, using the same one, what mass in grams of black iron oxide is produced? Okay? Well, we know that iron is my limiting reactant. Okay? So we'll use that, and we'll go back and figure out how much I actually will produce. So our starting point was 1.19964. 1.1996 moles of iron, and the ratio was 1 mole Fe3O4 to 3 moles of Fe. Alright, but it wants the answer in the mass, so I have to figure out Fe 55.85 times 3. O equals 16 times 4. So 64 plus 55.85 times 3 gives me a grand total 231.55 grams per mole black iron oxide. So this is giving me, if I stopped right here, I get an answer in moles. Fe3O4. Multiply this as 1 mole Fe3O4 to 231.55 grams. Fe3O4. So my units cancel, moles of iron, moles of iron, moles of iron oxide, moles of iron oxide, left with an answer in grams of iron oxide. So we do this math, 1.19964 times 231.55 divided by 3. Oops. And we get 92.592214 grams. And our original question had 3 significant figures. So we're going to produce 92.6 grams black iron oxide. Okay, so that's the answer to part B. Now, the answer question part C, what mass in grams of the excess reactant remains when the reaction is completed? Well, here I need to figure out how many moles of my product I actually produced. All right, we could do it with the iron oxide, but I already have an answer for moles of hydrogen gas, 1.5995. So we'll use that as our starting point. 1.595 moles H2. That's how much hydrogen I can produce. And we're trying to figure out the excess of how much of my excess reactant remains. So my excess reactant was water, so then we're going to ratio this. 4 moles of H2O from my equation to 4 moles of H2. So I actually only, so it's nice and easy, 1.5995 moles H2O are used. Okay. Well, how many moles did I start with? Well, I'm going to go back all the way to here. Oops, wrong page. Here, and we figure out that we started with this many, 1.99778. moles H2O to start, minus 1.5995 moles. This is my start value. This is my used value. Okay, so 1.99778 minus 1.5995, grand total of 0.39828 moles remain. Multiply that, 18.02 grams per mole. And we get an answer of 1.177 grams. Sorry, read that wrong. 7.177 grams, or an answer in 3 significant figures, 7.18 grams of hydrogen gas, of water left over when I do this reaction. Okay.